Oh, hey, hello, welcome to the show. It is time for John Park's workshop, and here we are in the workshop. I'm glad to have you. Thanks for joining. I have dirty glasses. What the heck happened? We're here. This is it. This is the workshop. This is the show. Thanks for tuning in. Thank you for the good people of YouTube chat. Dave Odessa, Beta Graf auf der Hagen, Johnny Bergdahl, Connor McCarter. Hello, hello, hello. And if you're somewhere where you're wondering where the chat is, because, wow, those are even worse, there's no chat. There is no chat that we're looking at least on some of those places. And he says, too much coffee, John? Funny you should say that. Who did I just talk to? I just talked to Andy Calloway. How? Well, the power of our Discord server. Go on over there. You can get there by going to adafruit.it/discord. And then you'll get an instant invite to our server. That's better. Look for the live broadcast chat channel. That's the one I have lit up right there. And there we have the aforementioned Andy Calloway, Paul Cutler. Hello, Starman. Howdy. Johnny Bergdahl is here as well. Hello. Hey, squid.jpg. NC Grover. Hello, 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 hello. Hey, Way90NY. Good afternoon to you too. So what is going on today? We have bigger pixels. So the continuation of this project. You can see it's gotten neatened up and biggened up since last week. This is a set of 4 of the 3mm pitch panels, matrix display panels. Last week we were working with these, which are awfully nice as well, but they're smaller. These are the little 2.5mm pitch, so you can see it's actually quite a big jump up in size. And this is for the Pico 8 wall-mounted arcade project. I also now, unlike last week, I believe it was just the Raspberry Pi 4 we were running last week. Now we're running it off of a Pi 5, thanks to some great work by Jeff Epler and Tim C. using PIO matter, which is allowing us to do fast, essentially shifting of pixels from the display bus instead of going over HDMI over to the bonnet that's plugged in, this thing you saw right here. And I've got that right there. See that little thing there? That's the little bonnet. It's now plugged into a Pi 5. The project previously was constrained to a Pi 4, but now we have this working well in 5, including keyboard support while it is running. I'll show you that. I've got gamepad support. We have gamepad support working in there now. Working on, I'll show a little bit of this bracket for actually putting together 4 of these panels in the back, and then we're going to be looking at some mounting options so we can make a nice, simple, minimal wall hanging arcade that we can play Pico 8 games on, or anything you want. Anything that you can display can essentially be shifted over, but a 128 by 128 pixel grid is kind of perfect for Pico 8 fantasy console. Turn off that HVAC that just kicked on. What else we have going on for the show today? I have a coupon code for you if you want to go to the Adafruit store, buy some neat stuff, and save 10% of your money. I will show you how to do that, the secret code you need. I will do a recap of my Tuesday show, which is JP's product pick of the week. And I've also got a pretty snazzy CircuitPython Parsec for you. I got distracted there as I was saying that because Andy Calloway said a Visa mount, John Park style. Yeah, so it's kind of that idea, right? There's semi-standard methods of the backs of these panels. I wish I had one just on its own. Let me unplug one of these so I can talk about these things. With our 3mm pitch ones, I'll show you a 2.5mm pitch one, these Hub 75 displays. We actually have a PDF in the downloads section for the product that shows two possible layouts of these holes as well as registration pins. There's a couple little protrusions you can see there. So I kind of had to account for those things for these particular ones, and it can vary. So it's I wish it were more standardized. But for what I'm working with here, for the ones we're selling, at least right now until a vendor changes or something like that, you'll be able to use the new design. This is a previous iteration, but the new design of these to essentially bolt 4 of them together. And then we still have outer mounts on them, which I'll probably be using to connect to the frame here that you'll see in a little bit when we get to that. They have magnet feet. We have magnet feet that you can use. That's what you see that I have on there. I may or may not be using some of those for mounting. It does make it nice because you can shift the group of 4 of them around. Once they're bound with my little bracket there, you can kind of align them and you don't have to worry about screwing them in from behind. So that might be a way to go. We'll see. Anyway, we'll dive more into that later. What else? So I've got a CircuitPython Parsec for you. I've got, I think that's it. And then the main project. Yeah? Yeah, so let's dive into it. Also, as always, let me know if you have questions or thoughts or comments over in the chats. I try to keep an eye on those. Dave Odessa says, looks like you've been busy. Yeah, I'll tell you, this was a, there was a lot of help from Tim, particularly, and Jeff Epler in actually making the software work to run this on Pi 5, which is really exciting. I was testing that and kind of going back and forth with Tim to make that work while I was working on the hardware mount side of this. But I think it'll pay off. I think it'll be a neat little gizmo. Oh, hey, Johnny Bergdahl says, here's my take on the same sort of thing, RGB matrix connectors. Look, let me open that up in a browser window and we'll take a look. This on printables, Chrome, Capture. Okay, so this is a Johnny Bergdahl P4 RGB matrix connectors. Oh, neat. Yeah. So these are for bridging the connections, the side-by-side connections. That's really helpful. Allows you to hook these together. It looks like you've made some feet as well that hook them up and make them stand on the desk. Really neat. Yeah, you know, I must confess, I didn't look around much to see if there were existing connectors for the backs of these. I probably should have, but I had the dimensional drawings there, so it was pretty quick to start putting something together. But thanks for sharing those. Those look really nice. Okay, so like I said, we've got a coupon code for you today. It is Shadowboxer, and that's because we're going to be building this in a shadow box sort of thing. But Shadowboxer, that is your coupon code. That will get you 10% off in the store. So head on over to adafruit.com. This right here, this is the store. Go find some neat stuff in the new products section. We have some pretty cool new things, including a new DAC. We've got these full RGB backlight diffuser panels. These are great for putting behind LCDs and things like that. They're nice little diffused color LEDs with sort of a lens and a diffuser. Now we've had those in, I think, just white, kind of a bluish white, and now we've got these full color ones, which is pretty snazzy. You can go to view all new products and check out what's new. Scroll through there, maybe get yourself some nudes, maybe get some filament letters. These are all in stock now, so you can put together some phrases or names or things like that. I believe we have numbers on the way as well, but if you want to get started with some letters, maybe make some sort of a Nixie clock kind of thing that spells out the time, I don't know. Those are some things you can get, and if you get those things, don't forget to save yourself 10% off in the store. Just type that in, Shadowboxer, to the coupon code field on the way out, and you will get a discount on everything except gift certificates, subscriptions, and software. But if it's physical goods that we can put in a box or a bag or an envelope, wrap it in a pita and staple it, I don't know what we're doing, but if you can do that, we can do this, and it'll be 10% off. Okay, next up, Tuesday show is my product pick, and that's what it looks like right there. That was this week's product pick. Here's a little 1-minute excerpt. Hey, look, that's the product pick of the week this week. It is the BQ25185 5-volt boost board. 6-volt panel. I can just put this outside and charge up the battery from it. I am charging it right now off of USB-C. I can unplug that, and you'll notice that I'm still running power, 5 volts boosted from the battery out to whatever I've got plugged into USB. This is just a little USB-C breakout that I have wired into the little screw terminals there. And then you can see my input side on V-in and ground is coming from the solar panel there. And then what I'm running off of it, actually, just for convenience, I put a small little USB-C to USB-A hub on the side here. And I have one of these very bright little LED rings that are great for doing some little local illumination. There is my product pick of the week this week. It is the BQ25185 5-volt boost board. Yeah, boy, that was the dramatic lighting yesterday, wasn't it? I've turned on some bench lighting now, but there you go. That was product pick. So let's see. Next up, did I mention we've got a CircuitPython Parsec? CircuitPython Parsec. Hey, oh right. Is this set? Yeah. Okay, this is good to go. Let's do this. So, for the CircuitPython Parsec today, I wanted to say that one more time. What am I going to show you? What did I call this? SD card detect. For the CircuitPython Parsec today, I wanted to show you how you can use the SD card detect inside of CircuitPython as a switch or a button. So on some of the SD card readers, including this one that's built on board with the Metro RP2350, there is a small switch in there that essentially throws a GPIO pin high or low when an SD card is inserted. So in this case, this is a really simple bit of code I have running. All we're going to do is see that the red onboard LED that's right here near where my finger is next to the green power LED, that is going to light up when an SD card is inserted. So I've got a little micro SD card. When I push that in, you'll see that lights up there, and then it turns off when I pull the SD card back out. And then you'll see I've also got a little bit of text showing up in the REPL there that says card inserted, LED on, card removed, LED off. The way you do this is by simply importing the board definition, which includes, for a board like this, board.sd card detect. It's really just a GPIO pin. In this case, it's going to be set to input with a pull-up resistor, and then I'm telling the LED to be enabled with a output direction, turn it off at first, and then I'm also checking the state of this switch. But otherwise, this is really just like throwing a switch. So you can see here, if the last state and the current state differ, sort of debouncing going on there, when the card comes out, we're going to turn the light off. When the card goes in, we're going to turn the light on. Now, this is essentially a bonus button, so you can see I'm just using it like a little button here. But ideally, you'll use this for cases where you want to do something when a card is plugged in or do something when a card is removed. So I've got a little bit of more complicated code here. I'm going to copy this and paste this over here and rerun it. And what this code is going to do is it's going to check for a card being inserted. When a card's inserted, it's going to check the name on the volume. If the volume is a known volume called cart1, it's going to light up the onboard NeoPixel to, actually when it's cart2, it's going to light the onboard NeoPixel to green. I'll unplug that. It'll reset the SD card hardware, and then when I plug in this other known cart, this one's called cart1, it lights up my NeoPixel purple. If I plug in a cart that I haven't named, that I'm not looking for, then it's going to kind of blink red and ask me to try again. So this is all an idea that I've had of doing some sort of like physical cartridges so that you could maybe play a game based on what you plug in, set up some sort of functions on a project by inserting and removing cards. But one of the key things there is to actually know when a card has been put in and one has been removed. In this case, it's all the same as what I showed before. I'm just setting up an SD card detect using that pin, setting it as a pull-up, and then doing stuff based on SD card being plugged in or removed. And so that is how you can use the SD card detect inside of CircuitPython with an SD card reader. And that is your CircuitPython Parsec. One other little bonus thing I wanted to show. I'm going to go to a full screen on this, and let's see if we can focus in really close on this part of the board. Almost. Oops, that's as close as that'll get. Let me back this out just a little so it's in focus. The SD card detect, you can see it right here. I'm going to get something to point with. Just use this for now. So right there, do you see that little sort of copper wire? That's a little spring contact. So it's a kind of a little switch. When the card goes in, let's see if I can do this and still keep the camera from moving, sorry. There you go. You'll see that's when it throws that switch, is when that little contact is made right there. So if you wanted to, you could actually take just a end of a screwdriver or something like that and bridge those two pieces ever so cautiously. And you can see there that will throw it as well, because it's the two pieces there touching each other. Normally they're separated by the spring action. So little bonus secret switch that you may not have realized you had on any of these boards that have a built-in SD card reader, or if you have an external one plugged in, it may, it's likely that it has that as well. Let's see. So that is CircuitPython Parsec for you. Next up, let's get a little sip of coffee, and we can start talking about this thing right here. So right now, what I have plugged in back here is that Raspberry Pi right there. That's a Pi 5. It has a bonnet on it, the Matrix Hub 75 LED Matrix driving bonnet with IDC cable plugged in for data. These are daisy chained around. Let's see if I can flip this around. You know, I'm not going to do that right now because I don't want to unplug anything, but we'll take a look at that in a minute. And then there's a 5-volt, 10-amp power supply giving power to the boards. I may actually try to go up to a couple of these or something bigger, because I think I'm getting a little flickering when there's a lot of color on screen, a lot of LEDs lit up, so I may be underpowering it a little bit. I haven't done the math on it for this many pixels, but it is 4 times 64 times 64, so many. Let's do the math on that. Hold on, I'll get my trusty phone calculator out. Let's see, it is 64 times 64, so that's 4,096 LEDs, or I should say 4,096 pixels. Each one has 3 elements, red, green, blue. But let's just do the pixel position math. So 4,096 times 4, 16,384 pixels for this display. I guess I could have done 128 times 128. Is that the same? 16,384. Now, if you multiply that by 60, that's kind of the current draw, I believe, on these. So 9, yeah, about 10 amps. So I'm right on the edge, I think, of what I can drive with that 10 amp supply. So it'd probably be wise to go up a little bit. Okay, so this is right now running headless, so I can't use this as my main display, like desktop Raspberry Pi. There's probably a way you could do it, but I'm not. What I've got is a SSH session into it. So let me share a window with you real quick. Let's do a new screen capture of, let's just do of a window. And that'll be terminal. Yeah? Okay. So I'll just put a little me in the corner there so you can see. So this is that Pi 5 over there. And I am running a virtual environment for the Blinka, so I can run Blinka CircuitPython essentially. And I'm in this Blinka Raspberry Pi 5 PO Matter directory in the examples. This is being updated right now by Tim. I think some of these examples you'll get, some you won't right now. And then what I'm running is I've made some little shell scripts that if you look at JPPPoW run, how about dots? I like the way this one looks. So what this is actually calling is Python virtual display keyboard selectors.py, script that Tim put together that allows us to do a virtual display as well as use the keyboard and selectors. I don't know what selector means in this case, honestly. The pinout is the Adafruit matrix BGR, so this is based on that Blinka PO Matter library that we've got installed. Back end, the XVFB, I think this is the frame buffer, taking the frame buffer and moving it over to the display. I've set width to 128, height to 128. Serpentine, that's the physical arrangement of these. So essentially this is, I think it's this one that goes into first. No, this one. So we go into this one facing up, facing up. This is actually a board facing down, facing down. So that's that serpentine arrangement. Works out pretty well from a piggybacking these types of ribbon cables into here. So you need some of these longer ones to make a couple of those runs there as we run the data. So this is the data. They're then also using the 5-volt power coming through that connector. Let me remove this one and I'll just stand to the side. And then I've got 5 address lines. That is when we're using a 64 by 64 display, we have the E-line selector set to pin 8. So you have essentially 5 ABCDE data lines running to this instead of the more typical 4 that you'll get on like the the 64 by 32 panels, the more rectangular ones. Number of planes, this refers to, I've got this set to 6, essentially the color depth. So for more accurate colors, you can go all the way up to 10. It also seems to be the best way to adjust brightness. So I think it's running fine at full color depth, but so far this is the easiest way I've found to tame the brightness, particularly for video, for showing video. And then I'm calling the Pico 8 software, which I showed last week, but go check it out. I think it still costs like $14 to get Pico 8, and then you can run all these virtual cartridges. You can develop your own games and applications on it, and it's got lots of great constraints to keep it tight. So this is a 64-bit version of that, and then I'm running a cartridge, in this case, the Dots 3D Pico 8 P8 cartridge. So if I can, let me sort of minimize this a little bit so you can see that screen. Let's see, I'll do it this way. Sorry, I'm just going to add one more video capture input of this camera so I can move it. That one there. And I'll zoom in on that a bit. There we go. So I'll run JP run dots 3D SH. So that was just a SSH. You can see that's the Pico 8 there. Here, this actually looks, this particular demo I think looks pretty good. Bare, naked, no diffuser on it, especially on video. In real life, it actually kind of looks better to me once I put this diffuser on. Actually, yeah, it looks pretty good on video. So this is a 12-inch by 12-inch piece of LED acrylic. They're this kind of acrylic's designed for this, for making LEDs look nice. I've just ordered a 16-inch by 16-inch slice from Tap Plastics. This is the biggest that Adafruit sells. It's 12 by 12. So this is a little under 16 inches square for these two. So I've got a 16-inch, 16-inch coming that I'm going to use. I may end up, depending on how hardware mounting into my shadow box goes, if I can build a sort of mat around that, I may just stick with that, or I may actually reorder a nearly 20-inch by 20-inch piece because of the, this is the mat for the shadow box that I'm using, and that's about 20 by 20 inches. So this is too much mat. It's going to cut into it too much, but I'll show you that in a second. So there is the demo running right now. Nice thing is that we have, thanks to the work that Tim and Jepler did, keyboard pass-through as well as direct control from a game controller. So keyboard could be one that's plugged in directly, or it can be over SSH. This is working the same. So that means if I hit escape, I've just paused my demo that was running. I've paused my cartridge, and I've gone out to the shell, essentially, of Pico 8. I can do CLS, clear screen, and you should be able to see, yeah, you should be able to see it just on here. So this is a little prompt with a blinking cursor. I can type in help here, and that'll show me the Pico 8 help screen. Get that reflection off of there. So this gives you some idea of some of the commands that you can type in there, and we can do things like run explore, which is the explorer. That, again, looks great in real life, but is super blinky on video, so sorry about that. But this is a nice little explorer where we can go through and check for different games that we've downloaded. It's got a connection to their BBS server thing, so we can run, let's say, Celeste 2. I don't have any audio hooked up to this right now. Actually, when I've had the HDMI plugged in simultaneously to a monitor that has speakers on it. I'm hearing that sound, but I need to look into other ways to get audio working. So so this is the nice little whoa, I'm gonna die. Nice little Celeste version running on there. I don't have any escape key kind of stuff mapped on here. If I am able to do that, and I think I can, you can capture the controller mappings and then tell it that you want to map something like the start or the select button to be escape, which helps you get back out to explore. We can exit out explore there and then go pick from different demos, etc. Here's a list of the cartridges that are on board. Oops. Let's see. Yeah, so here's that one I was showing last week, the Waves demo, which I really like. Looking cool. So that's it running on the 3mm pitch. So we're a lot bigger than last week. And now the next question is, how are we going to mount this thing so that we can put it up on the wall? So let's take a journey over to the workbench here, which I think I've got to calm the brightness of the exposure there a little bit, especially because we're looking at that white background. So I went to IKEA last night and picked up, let me set my coffee over here where I won't knock it over. That's a little better. So I went and picked up one of these sort of shadow box frames. So this is still got its protective film over it there, but that's clear. And these are pretty neat because they've got a couple of configurations for them. Zoom out a little more. So it has this inner frame spacer thing, which allows you to use it like a shadow box. So if we take off the glass, essentially, and set this in first, you can then lay down what I'll call the glass. Should be symmetrical. Let me just get it in place. And this is what I may just use if I get a 20 by 20 inch piece of the LED acrylic, I may move that to the front, place that in first, then pack in my panels. But I'll just show you, this is how this is meant to go. I'll just skip that piece, and here's the hanger back. So you can see you get a nice deep shadow box style thing there. So that would be pretty cool if I get the right border on there for having this display, and the acrylic in the front is what I think will make it look a little more like a display, more like a very low resolution CRT kind of look to some degree. So I'm not going to use that mat. Let's get that out of there. Get this out of here. And for now, I will place this clear screen just in the front. We can pretend that's the LED acrylic. And actually, I can probably put I have a couple slices of the 12-inch stuff there, so you can kind of see what that will look like. And oh, I'm breaking it already. Yes. I don't know if that was meant to come off that easy. It's probably just like a little bit of glue. Yeah, they put a tiny little bit of glue. So I was also thinking this may be something I can I can cut and alter this little inner box. I got 2 of these frames. One of them was in their used section for $15. It was essentially new, just the wrapper was off of it. And then the second one I got is brand new, $20 new, I think. But this, yeah, this little piece here might be neat for cutting and laying in this way. There's a chance that'll give me the size I want. Let's grab a tape measure. So let's see. This thing, I believe, is, yeah, just like 19 3/4 inches on the interior. That little piece there is about 1 3/4 inches. So that's almost perfect. That may just get me down to 16 by 16 by 16 to lay in. And then that'll look kind of cool there to have that little extra red border. So I'm glad I got 2 of these. I'll probably still have to do some alterations, but if I place, cut, those 4 in there, and then set in my acrylic, and then set in my LED matrix, that might work well. So let's slide that back in there. Yeah, these outer ones are just held by a tiny corner staple. So the whole thing could be reformed a little bit. This, I think, just has like a vinyl. The red is like a vinyl on there, so you can't hide some of the cuts depending on what you do. But so that'll go like that. Pretend that's the bigger piece. I don't think I can fit 2 in there. And then these panels will be connected in there. So let's take a look at the full set of 4 panels here. I'm going to shut this down and let's grab that. So let me go back to this view for a second. So I'm going to quit this. That ends just the Pico 8 session there. And then I'll do a shutdown. Oh, what's the -H now? Yeah. That do it? Yeah, okay, so I shut that down. So this Pi is off. And I'm just gonna unplug power and I'll leave the Pi plugged into these. Because kind of the important phase 2 of this operation is, does all the stuff fit in there, and how will I access the connections that I need? How will I mount the Pi? So let's go back over here. And get rid of that. So yeah, this is actually kind of a nice bit of room there. And here you can see this is the mount. There's a second iteration of the mount. One thing I've gotten in the habit of doing with iterations on 3D printed designs is just changing the color on each print. And I'm not keeping, track of which color was which version that much, but at least I know that the newer print happened to be this green one. The first one was this red one. So you can see I added symmetrical holes so that I could, these holes are not even on some of these parts. Some of them are, the holes in the panels. Move that down there. So I've made it possible to, since these are rotated 90 degree or 180 on the bottom row, I needed to make a provision for that. So every hole on here, unlike the first version where it was just some of the offset ones. Now all of them are symmetrical, so you can kind of arrange these any way you like and still screw them together. So that'll have the acrylic screen in front of it and then be mounted inside like that. Hopefully I don't pop that acrylic out. And that's what that looks like there. And then maybe I'll have those little red spacers in place. Let's see. See how those will go. I think it'll be like that. That's centered there. And then we'll see. Yeah, I'm wondering if my 16-inch piece of acrylic will meet up there. I don't think it will. So we'll see how I solve that. I don't want to. I mean, this is big enough that I have a laser cutter that only has a 12-inch by 16-inch bed on it, so I can't really work at this scale and make a nice, easy frame for myself. So I may just be using a table saw or hand saws or something like that to do some adjustments. So we'll see. Maybe another little inner bezel could be made with connected 3D printed parts, but again, I can't do a part that big 3D printed, so we'll see. We'll see. Let me set this off to the side. The Pi, you can see, will probably I'll have a connection to the back of the panel as well. So that's resting in here, something like that. That still gives me a flush to the back of the wall type of experience. Pop this in here. So this all should fit there, which is great, and we have a little lip there still. So we'll see about a hanger. I don't trust just this little thing here for hanging this whole thing on the wall, but we can also place some screws under here and hook it. So yeah, this would go here. I'll probably just put some holes in this to allow for wire management, or do a cutout on the back there so that I just have the bare parts that I need access to on here. And then coming out the front will be the controls, maybe just the game controller. I might try a Bluetooth controller so that I have nothing to come out to the front. Ideally, put this right over an outlet and you don't have any wires going to it at all. If you have a high-mounted outlet, that would be great. Otherwise, maybe a little outlet strip will run up the wall from an outlet so that you can sort of hide that. So I think that's the plan. I'm going to try to put this together pretty quickly, try to avoid as much custom work as I can, make this something that you can put together without too much trouble. So we'll see where I arrive at that, but that's the idea there. I'm not going to turn this one on now just because I don't have the big diffuser in there, and I might pop that through the front. But there we go. That's the arcade idea. Oh yeah, here's a nice. I've been meaning to talk about these. Thank you for Yanisku7 posted over in the Discord. Nice wall mount. There's some nice wall-mounted arcades out there. I like this one. I like the. Let me go back to my browser here. Love Halton. Has this, some of these nice looking ones here. Beautiful. I'm not planning to do this. I'm not planning to do a set of arcade controls on there, but that's a nice, visually, it's gorgeous. It's a nice nice idea, and mine will cost less than $4,799 US dollars, I hope. Should. Just to play some Pico 8. All right. So let's see. Other thoughts or questions? Let me know. Relic says, I'd love to have a Pico 8 machine in my local arcade pub. Yeah, that would be a cool one. I like that. Oh, good point. Yeah, so C. Grover said you're going to probably need to vent the cooling for up to 50 watts of heat. A very good point. Yeah, so definitely some holes in the back of this thing. I may put the little Raspberry Pi fan just to keep it from overheating, at least get some air moving, but maybe a small, maybe a little 5-volt. We have some of these little 5-volt fans that have come in recently. I think they're USB. Would be a good idea maybe to move some air through, put one of those to draw some air from one side to the other. Johnny Burdell says water cooling. It's going to be the world's only water-cooled Pico 8. Hope it doesn't need that. Yeah, good point. Thank you. Cooling. Don't want this overheating. Don't want a big box of heat sitting against the wall. So this is important stuff to consider. All right. Well, I think that's going to do it then for the show. Before I go, I will remind you, if you want to save some money in the Adafruit store today, go check that out right there. Shadow Boxer. That's your coupon code. Go to the store, get some stuff. Maybe get a Raspberry Pi 5. You can get 10% off of it. We don't even have restrictions on those anymore. Shadow Boxer will get you the 10% off in the store. Continuing on the conversation about cooling, John Nodge said maybe have some standoffs on the back so that it allows some back venting rather than worrying about on the sides. Very good idea. So I'll play around with some of those thoughts. Or top venting, mount it high enough that maybe I can cut some holes up in the top. Yeah, and I can set my coffee mug on top of there and warm it. Okay, hey, thanks everyone so much for stopping by. Have a great weekend. You can stop on by tomorrow for a deep dive with Tim C. And I believe there'll be a Desk of Lady Ada at some point on the weekend. And we'll be back with all of our shows next week. Thanks everyone for Adafruit Industries. I'm John Park, and this has been John Park's Workshop. Bye-bye.
Thank you.